This is rapidchange Revo, E3D's new 3D printing hot end. Even though its heatsink looks very similar to an old V6, everything below is brand new, innovative, and might make 3D printing easier, more convenient, and safe. I had a great time testing it the last 2.5 months. Never changed so many nozzles so conveniently. But also had one fail on me and discovered some things during my tests that you should know about if you already use one or if you consider buying one. Let's find out more. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. Before we start, a quick word about today's sponsor Grammarly. Grammarly is a writing assistant that supports clean and mistake-free writing by offering suggestions that go way beyond grammar. You may be surprised to know, but even before becoming a sponsor, Grammarly helped me create my videos. I've been using Grammarly Premium myself for over 2 years now. It assists me in writing more clean and fluid scripts, just like this one, and helps me prevent embarrassing mistakes on social media because Twitter doesn't have an edit button. I also like Grammarly's full sentence rewrite feature, which helps me to effectively convey my ideas and avoid miscommunication by rewriting hard to read sentences. We're all constantly writing emails, messages, and posting on social media, where we want to make sure not to make embarrassing mistakes and bring our message across in a concise way. Use my link grammarly.com/cnckitchen to sign up today for Grammarly's free version, which will already help you out a ton with analyzing your writing by using AI-assisted grammar and spell checking. All available on your phone and on desktop. It doesn't matter if you're a student or a professional, start writing better by keeping it concise, confident, and effective with Grammarly. Go to grammarly.com/cnckitchen to sign up for a free account. And when you're ready to update to Grammarly Premium, get 20% off for being my viewer. rapidchange Revo is E3D's new hot-end ecosystem. As the name rapidchange already suggests, one of the main advertised features of Revo is the ease and convenience of nozzle changes, because no tools are needed and it can and should be done while the hot end is cold. But E3D did more than this, because they also integrated components to make the system more compact, capable, reliable, and safe. Their heater cores, for example, combine the heater block, a heating element, and the thermistor. The new dual material NozzleBreaks combine a brass nozzle with a thin stainless steel tube as a heat break, eliminating the need for hot tightening and preventing material leaks. I've been thoroughly testing Revo for several hundred hours with excellent prints, failed hardware, and very interesting discoveries during my performance and in-depth thermal tests. Revo is its own ecosystem, which means that you need to replace the whole hot end if you want to use it on your printer. The Revo 6 is a drop-in replacement for the old V6 hot end. Its length, the heatsink, and the groove mount have exactly the same dimensions. Then there is Revo Micro, which is a small and lighter version, suitable for compact machines and fast printing, where low weight is essential. And since the Revo nozzles have exactly the same interface that was introduced with the Hemera extruder, there is also Revo Hemera. You can install the Revo hot side on an old Hemera without a problem, but the spring that usually connects the heatsink to the heater core doesn't connect, so you lose this feature. E3D offers an upgrade kit for Hemera if this is important for you. Then there is a Revo heatsink for wall-run machines with a 4-screw mount on the top. E3D also teased Revo CR, a drop-in replacement for the typical Creality style hot ends that should release soon. Revo CR will use the same thermistor as Creality machines, so there won't be any firmware changes necessary. At the time of releasing this video, there were only the brass nozzles available from E3D. They will be releasing their abrasion-resistant nozzles shortly, but if you install Revo right now, you won't be able to print any abrasive materials. E3D also recently talked about a high-flow variant of Revo. I'm quite excited to find out if they use the simple long melt zone approach from Volcano, or if they use some of the technology I found in one of their patents, in which they shape a tube that's part of the flow path and embed that in a heater. That's also where another E3D patent on Revo comes in. On their website, they link to a design patent in which they protect the appearance of the Revo nozzles, which means that we won't be finding either cheap replacement or abrasion-resistant nozzles from third-party vendors soon, if they don't have a license agreement with E3D. The cold side is still open source, so if you want to use Revo nozzles and heater cores with your heatsink or extruder, you still can. In a way, I do understand E3D because they poured a ton of R&D money into Revo and don't want others simply and often in a worse way, copying what they worked so hard for. Still, it's a bit against the spirit of RapRap, but I think we have to deal with this if we want to get away from DIY solutions to reliably working systems. Let's also talk about prices. I use the prices from the E3D shop. Your local prices may slightly vary. Compared to an Assemble V6, Revo 6 is around 40% more expensive and sells for 70 British pounds. A nozzle or better NozzleBreak costs 19 pounds or a bit less if you buy a set compared to around 420 for a V6 nozzle, but well, it comes with an included heat break. A new heater core, if you ever needed one, is 2350. It is more expensive than V6, but still, in my opinion, reasonably priced and very much in the range of what other extrusion systems costs, and it offers some very unique features others don't have. Revo is currently sold out in many places due to the high demand, but I tried to link some shops below where you might still be able to find one. Some of them are affiliate links, but it's a way to support the channel. I used Revo 6 for my tests and replaced my regular V6 hot end in my Prusa Mark III's. The procedure is well documented by E3D and fairly easy to do. It does require routing new wires into the electronics box and takes maybe around an hour to finish. Revo uses these Molex connectors that I zip tied to the wiring sleeve. It's not super pretty, but I can look over that. No firmware changes are required because Revo uses the same Semitech 104 GT thermistor as the older V6. Only a short PID tune and first layer calibration are necessary to make it ready for printing. To judge and compare print quality, I printed 3D benchies with the old V6 hot end and then the Revo hot end using PLA, PETG and ABS. The results look basically identical, with a tiny bit less stringing on the Revo, so I'm quite certain that we can expect the same and even slightly better printing quality that we already know from E3D's old V6 extrusion system. I also printed a ton of ABS parts and even Prusa PC blend and didn't have any problems with extrusions, clocks or quality. But let's talk about rapidchange, Revo's eponymous feature, changing nozzles fast and conveniently. I think I know what I'm talking about, because I changed tons of nozzles and killed plenty of heater blocks over the years. In the past, I rarely changed nozzles, just to print with a different nozzle size, but with Revo I noticed it became so convenient that I way more often quickly changed to a 0.6mm nozzle if I had to print a bigger or sturdier part. What makes changing nozzles on Revo fast and convenient is that the nozzle and the heat break are one piece, so it doesn't need to be hot tightened. The nozzle breaks are made from 3 different parts, with a brass nozzle tip, a thin stainless steel tube, and a brass upper section that screws into the hot end. These are press fit together in factory and ensure that no material leaks during printing, even at higher temperatures. The nozzles are equipped with different colored socks to easily distinguish sizes, so no more counting buried holes under a layer of carbonized plastic. And even if you lose a sock, the nozzles are now beautifully engraved with the orifice size. You simply screw out the nozzle with your finger, which can be a bit tight depending on the fan shroud you use, and replace it with another one. A spring holds the heater core in place so it doesn't fall down, and when the nozzle gets installed, it makes sure that the core is firmly pressed onto the nozzle for good thermal contact. No tools are required, and you only screw in the nozzle finger tight. Of course, you need to make sure that no filament is loaded. You either heat the hot end first, remove the material, and wait for it to cool down again, or you add a line to your NG code to retract the filament after each print. If I would benchmark the time that it takes me to change a nozzle on a V6 in its hot state and compare it to the time that it takes me to first remove the filament on a Revo, let it cool down again, and then change the nozzle, the old system would probably even win. If no filament is loaded on Revo, it's seriously fast though. And the convenience of Revo is that I don't need eddy tools for the process, and that it significantly reduces the risk of burning your fingers. And if you're someone who is regularly changing nozzles, you'll also know how fragile aluminum heater blocks are. I already stripped the threads out of several ones due to threading and lower material properties at these elevated temperatures. And if you're not adequately holding the heater block, you can even rip wires or bend the heat break. Revo eliminates all of these risks with the integrated nozzle brake and should ensure a long life of the nozzle and the heater core. E3D also tried to make sure to have very tight tolerances on the distance between the mating surface to the heater block and the tip of the nozzle, so that no first layer calibration should be necessary. I'm sure this is challenging because the precision of the press fitting process needs to be very high, and there seems to have been a problem with some of the beta units. These deviated in length by some tenths of a millimeter. This got fixed with retail parts that are very similar in length now. Suppose you've watched my previous videos or maybe follow me on Instagram or Twitter. In that case, you'll know that I love cold pulling during material changes, simply to remove all of the residues and reduce the necessity of purging. Revo makes this even simpler because not only are the internal surfaces super smooth, but there is basically no undercut between the nozzle and the heat break. Hence, filament slides out really easily. Don't let my cut-ups fool you, because that was a beta nozzle with a length problem and a small centricity problem. Let's now talk about the heater core, which integrates the heater block, heater cartridge and the thermistor into one component. The heater cores have 40 watts of nominal power, which is sufficient for the flow rates you will be using Revo. I said 40 watts nominal power because Revo uses a PTC heating element. PTC means positive temperature coefficient, which means its resistance rises with higher temperatures, giving it less power, and therefore is an inherent way of reducing the potential of melting down and catching fire. Tom Sanladerer did an excellent investigation on Revo's electrical properties, and I highly recommend checking out his video. The heating element wraps around the nickel-plated heater core and has an integrated thermistor on the top. The thing I like most about this design is that the wires from the heater and thermistor are properly strain relieved, which almost completely eliminates the risk of ripping off wires or shorting something out. Great job! Heat up times are faster, and judging from the numbers on the screen, Revo takes 60 seconds to get to 210 degrees Celsius, whereas the old V6 takes 1.5 minutes at the same 40 watts of heating power. But now the really interesting part of this video starts. Let's look at the heater core, nozzle and thermistor setup. On a classic V6 and many other hot ends, you have the heater cartridge on one side of the heater block, the thermistor on the other. The nozzle sits in the middle. There will always be a temperature gradient between heater and thermistor, and since the nozzle sits in between, it should be right at around the average temperature. On ring heaters like Revo, the configuration is different. The heating element wraps all around the heater, and the thermistor usually sits in between the start and the end. There will still be a temperature gradient because the filament and convection around the nozzle sucks heat away, but it will be circular instead of linear. Since the thermistor sits on the outside, close to the heater, it will report its temperature, but it doesn't have a clue what the temperature within the nozzle is. I tested that by simply sticking a thermocouple down the filament path. On the old V6, the display temperature and the real temperature are very close, and the final temperature matches almost perfectly. On Revo it's very different. We can see how fast the reported temperature rises. On the other hand, the real temperature within the nozzle drastically lags behind because it takes some time to get there. Also, the final temperature is 3 degrees below the displayed one, due to the temperature gradient. This means that Revo actually cheats, and it only seems that it heats up way faster than a regular hot end. In my opinion, it doesn't have a huge impact on practical applications, because heating the bed is always taking longer than heating the nozzle. Still, I think Revo cannot react as dynamically to temperature changes as one might think. The thermal mass though might help a little. There is one case where this was really annoying for me. As said previously, I really like to cold pull my filament, which I do during heat up, and for PLA at around 65 degrees Celsius. On Revo, I have to wait until the printer displays a good 100 degrees Celsius, because the temperature is not reported correctly. And just to tease you a little, it will become even more interesting in a bit. Since the filament path was clean and I had my thermocouples out, I also did another test I haven't seen anyone else do yet. My thermistor wire is conveniently around 1.5 mm thick, engaging with the feeder gears. This way I was able to write a short G-code that retracts the thermocouple by a millimeter and then waits 30 seconds and does that over and over again until I mapped the whole filament path. This let me check how well the heat break works, how long the melt zone is, and if there's any heat creep. On a standard V6, the temperature stays pretty stable within the first 8 mm, then slowly starts dropping when the stainless steel heat break starts, sharply drops within the thin section, and then stabilizes at around 36 degrees Celsius. Revo starts slightly lower, but keeps a very stable temperature profile up to around 12 mm, due to the long brass section of the nozzle. Then it also sharply drops off and stabilizes at the same, maybe even slightly lower temperature within the heatsink. This tells us a couple of things. The melt zone is not only a bit longer, but the stainless steel tube used as a heat break does an excellent job, and the heatsink that's only cooled by a quiet Noctua fan prevents heat creep efficiently. Just for completeness, I did the same test for an E3D Volcano as well, where we can see the longer melt zone, the sharp drop off, and a very similar final temperature. Let's now get to Revo's dirty secret. I did all of the tests without a part cooling fan, though I turned it on manually to cool the hot end down quicker after one of the tests and forgot to turn it off before the next one. I wondered why the measured temperatures within the hot end suddenly was around 10 degrees lower than before. I double and triple checked everything, but it turned out that due to the thermistor and heater configuration, Revo doesn't notice when the part cooling fan cools down the nozzle in a way, as it is the case with the old V6 setup. Part cooling increases the temperature gradient between the center and the outside, leading to 5% difference between the set and real temperature. V6 doesn't have that problem because the nozzle sits in between the heater and the thermistor and even slightly raises the nozzle temperature. This is also confirmed by the measurements I did. Revo drops in temperatures from 206 degrees Celsius to 197 degrees Celsius within the whole melt zone, whereas V6 increases its temperature from 208 to 209 degrees Celsius. I made a custom all-around heater sock which reduces the problem slightly, but in the end it's a problem of the ring heater design and probably hard to mitigate. Is this a deal breaker for Revo? I don't think so, because when cooling is constant, the temperature drop will stay the same, and you usually tune extrusion temperatures in a printing profile. But if you are using existing profiles with part cooling, I'd recommend rising the temperature by 5 to 10 degrees Celsius if you want to retain a similar part strength. Honestly, I'm sure that other hot ends on the market show a similar effect, but nobody measured and nobody noticed it because they work fine as well. Let's finally take a quick look at the extrusion performance of Revo and compare it to V6. I first did a simple extrusion test by feeding 200 mm of PLA at 210 degrees Celsius set nozzle temperature through the hot end and measured how much material I really extruded. Up to 15 cubic millimeters a second, both hot ends performed very similarly and there was barely a visible difference. Only at higher melting rates, there seemed to be a noticeable yet slight difference. So even though the melt zone of Revo seems to be slightly longer, the impact on the extrusion rate is minimal. As a more realistic test, I also printed meandering test parts where I increased the print speed every 5 mm, starting from extrusion rates of 10 cubic millimeters a second to 20 cubic millimeters a second. Here, Revo was a bit better than the old V6 and managed to even finish 16 cubic millimeters a second, which didn't work with V6. In the end, both aren't high flow hot ends, but the flow rates they are able to achieve should be sufficient for 90% of users printing with a 0.4mm nozzle. I have to mention that I had one Revo print core fail on me during the 200 hours of printing test parts for the upcoming Voron 2.4 build. At some point, the temperatures reported back to the printer were significantly too low and jumped around starting at 170 degrees Celsius. E3D replaced my heater core and told me this was a very rare event and probably caused by a poorly assembled unit where the insulation of the thermistor slowly failed, changing the measured resistance of the thermistor. This doesn't seem to be a serious problem, but they are taking measures to prevent that from happening in the future. Still, if you think you have a similar behavior on your heater core, contact E3D supports for assistance. So, in summary, do I think Revo is the long-awaited successor to V6, and should you be buying one? It is a bit more expensive than the older hot end, and for the moment there aren't any abrasion resistant or high flow nozzles available. The temperature drop isn't great, but in my opinion, no deal breaker. Everything else is really nice. Nozzle swapping is way more convenient. And where in the past I changed nozzles maybe once every other month, I find myself now selecting a suitable size for every print that I do. The heater core is excellent, it uses less space and will allow better cooling solutions, but the most valuable thing is the properly strain relieved wires. Everyone who had already a big blob of material around their hot end will know that damaging wires on other common solutions is so easy. The Revo heater core is so much more robust and should outlast your printer's life if E3D does proper QC in the future. Still, if you have a printer that works and you always print with the same nozzle, Revo probably won't tremendously improve your machine's performance. So if you anyways wanted to replace your old hot end, or if you'd like to change between nozzle sizes easier, I'm very sure that you'll love E3D's new hot end. And for around $100, it's probably the best value for money option that you can find right now. Revo is the worthy successor to V6, and as soon as the Obsidian nozzles and high flow variants drop, will be the new go-to hot end for printers. Will I replacing all of my hot ends with Revo? Not right now, because I still need machines on which I can test nozzles from third parties. But on my Prusa, for example, which I use a ton to print unreinforced materials, Revo will be a game changer in convenience. But what are your thoughts? Have you already ordered a Revo? Do you think about it, or is there a reason that Revo isn't for you? Leave a comment down below. Thanks for watching. I hope you found this review interesting. If you want to support my work, consider becoming a patron or a YouTube member and check out the other videos in my library. I hope to see you in the next one. Auf Wiedersehen and goodbye. Adequately.